Very special welcome to Bite-Sized Info, Edition 3. Bite-Sized Info is still new, with this being only the third one, but we trust you've enjoyed the first two. If you need to catch up, they're on the Tropical Bites website. Today's Bite-Sized Info is on the macadamia flower, how it looks, how it behaves, and how it's fertilized. Because pollination is key to nut set, and that is key to productivity, understanding the flower, where and how that pollination is happening is foundational to optimizing farmer success. There's a lot more detail on this topic in a story called Flowers to Nuts. This can be found on the website under the JAF and Other Stories tab. Should suppliers be interested in advertising, it is here that your advert would appear. All the relevant detail is also on the website under the Advertise tab. Okay, so let's explain what is happening scientifically in the development of your mac flowers. Mac flowers develop on long racemes where about 500 to 800 flowers will start out. The different mac cultivars have different characteristics regarding the length of their racemes, the color of the flowers, whether the racemes sprout from new or old wood, and at what age the trees start to flower. Regardless of all these factors, all mac flowers have the same basic construct and fertilization or pollination process. It all starts with a bud, and here you can see them on a new raceme. These buds elongate and then the sepal casing starts to split as the flower opens. Through this split, the bent style is seen protruding. This is part of the immature female bits as she starts to get outside the flower and away from the male bits of her flower before she's fully mature. This escape prevents self-pollination of the flower. Remember this for later. And then the next stage we're looking at is anthesis, which is when the flowers are fully open and they look like little stars. During this stage, the male bits are also exposed. We all know that genetic diversity results in a stronger specimen, be that a human, an animal, or a mac nut. To increase the odds that a mac flower is pollinated by other genetic material rather than its own pollen, its male and female parts mature at different times. This characteristic is known as protandrous. So let's zoom in and look at the individual parts of a mac flower to understand how a nut begins. This is a single mature mac flower. These are the female parts, collectively known as the pistil. It's made up of the stigma, the style, and the ovary. The male parts consist of 4 stamens, each topped with anthers containing the pollen sacs. And these are the sepals which have curled back to expose the important parts. Every flower has a nectar basin which attracts insects so that they can facilitate the process. They will transfer ripe pollen from the stamens of other flowers onto the receptive stigma, and it'll travel down the style and fertilize the ovary, completing stage 1 of the new nut. If everything is healthy, the new nut will set and grow. The sepals will dry up and fall off. If you look closely at the point where the flower became the stalk attached to the raceme, you'll see a few swollen bumps, which are the beginnings of nuts. For some aside trivia, have you noticed that we're saying sepals here and not petals? A mac flower doesn't have petals like a rose does. It only has what we are used to seeing as small green leaves between the stem and the petals of a flower, and these are called sepals. So for between 4 and 7 weeks after the sepals have fallen off, there will be rapid growth of the fertilized ovary. And up until 60 days after anthesis, young nuts will drop continuously, but those that make the 2-month mark are usually there for the long haul. The racemes will dry and harden to carry the load. Note how the raceme up to the nut has thickened and strengthened, while the raceme beyond the nut has shriveled. About 110 days, almost 4 months after anthesis, the shell will harden and the nut weighs about 70% of what it will at full maturity. From here, it's a 90-day wait until the nut enlarges a little with accumulated water, but oil production is the key activity, the conclusion of which is an energy-rich, nutritious mac nut ready for harvesting. So how do we use this info to make sure we have this instead of this? Obviously, these are two different cultivars, but you get what I mean. How can we use what we know to improve our outcomes? From experience, we know that macadamia trees don't seem to have any issues generating an abundance of buds or in developing those buds to flowers. The issues, from a mac farmer's perspective, seem to lie in keeping those nuts on the tree. So let's investigate what factors affect those developments. Pollination is undoubtedly the fundamental requirement for any yield at all. Factors affecting the quality of pollination are pollinator efficacy. Pollinators are key in making the transfer of pollen to ovaries. These insects need to be sufficient to get the job done across the entire orchard. Factors that affect insect numbers in our orchards are spray programs, the lure of other food sources, supplementation, whether you hire in hives or use your own established hives, and predators. Pollinator efficacy is also strongly linked to insect health, and their health is influenced by the natural environment, the shelter options that they have, diseases and food around the orchard, and the spray programs that you're following in your orchard. Weather also makes a profound impact on pollinators. For example, insect activity is reduced by cold, wet, and windy conditions, but they work really well on still, dry, and warm days. So, along with all its influencing factors, pollination most certainly affects yield. What else? Quality or stickability of that nut set. In other words, is this a healthy embryo? Will it last to full term? Just as in the fauna world, weak, poorly bred and diseased embryos will abort. Factors affecting this are genetic quality. Cross-pollination will improve the genetic quality of a nut, which will not only improve its stickability, but its whole development and ultimately the overall orchard yield. Pathogens present during flowering, things like fungi, etc., will impact whether or not a nut sticks. The health of the host, mother tree, is also important. Tree health is influenced by the environment and nutritional resources. Damaged embryos are less likely to stick. Things like insects and the elements, hail, wind, sun, etc., can affect embryo integrity. So we can bank another solid factor in yield, which is stickability of the nuts. What else? Tree capacity. Once the ovary is fertilized and pollination is complete, a nut is set. But even the strongest, healthiest macadamia tree is not designed to carry all the nuts that set, especially if fertilization was highly effective. We can see this by the mere fact that a raceme is not big enough to carry 500 nuts. It is impossible for all flowers, even if they're all effectively pollinated, to make it to final set. November dump is when the tree aligns its load to its capacity. By increasing the tree's capacity, we can increase the final nut set, limited only by the size of the raceme. Factors affecting capacity are tree health. Obviously, a healthy tree will have the resources to carry more than an unhealthy one. In assessing its health, a tree does not take only its current condition into account, it also factors in the last 2 to 3 years. The water availability, nutrition availability, disease pressure over the recent years will determine how prepared or healthy it feels. Now, I can hear some of you disagreeing with me because you've seen sick trees carrying a heavy crop. This is different and is not sustainable farming. So let me explain what is happening there. It's a survival mechanism. wherein the tree is putting its energy into reproduction rather than its own growth. It is stressed and ready to die. So, to maximize its chances of passing on its genes through seed dispersal, it produces a lot of seed. The quality of the fruit produced on a sick tree is usually significantly lower. Besides health, a tree's capacity is also impacted by the genetic characteristics of a particular cultivar, the environmental conditions, like the climate. So we add capacity to the list of limiting factors and can now look at the fourth element, which is mechanical damage. These are external factors damaging the tree and also include things like insects, all those pests we spend so much time fighting off, and then sometimes extreme weather like hail and heavy winds can severely damage even well-attached strong nuts. In summary, if we focus on optimizing conditions around these four factors, we'll be able to impact yield positively. Even small steps in improving each area will begin the journey towards greater returns. And that brings us to an end of this bite-sized info. Remember that advert pages will appear again at the end of each edition. Please share this opportunity with companies you know will benefit from putting their brand in front of this audience. Until next time, God bless.